So today I want to talk about proving the Pythagorean Theorem. So our question of the day is, how can I show that the Pythagorean Theorem is true? Now we've done some activities in the past where we cut some things up and show that certain squares fit inside other squares. And you've shown for that particular triangle that that's true, but those activities are using inductive reasoning. In other words, you've looked at examples of certain right triangles. You've looked at the squares created from their sides and seen that the area of the A square plus the area of the B square is equal to the area of the C square. But that doesn't prove it for every right triangle. It just proves it for those triangles that we looked at, those 3 or 4 or 5. What we want to do is do something different. We want to use deductive reasoning to prove that it's always true. So to prove that something's always true, we are going to come up with an argument which works for any right triangle. No matter what the side lengths are, this proof will show you that A squared, the length of one leg, squared, plus B squared, the length of the other leg squared, has to equal the square of the length of the hypotenuse across there. So we want to show that A squared plus B squared is C squared, and this is a random triangle, and the length of one leg is A. The length of the other leg is B, and if you square both of those and add them together, it's going to equal the length of the third leg, which is C. Now notice that I'm using variables to indicate lengths so that whatever I'm going to say is true for any combination of lengths that occur in a right triangle. That's what's going to make this so powerful here. So here's my triangle, and this is where the creativity of a proof comes in, because you have to figure out how to start this, and this is where the beauty of a proof comes. Is somebody figured out that if you take a triangle and you make 4 copies of it and you arrange it into this particular configuration, that some interesting things happen. So let's take a look at this. Now notice that I have a shape here. It looks like it's a square, and in fact it is a square. The sides are all A plus B, and I have right angles also in all the corners here because my original triangle is a right triangle, and that means that I get a right angle here, a right angle here, a right angle here, and a right angle here, because those are all copies of the same right triangle. So I have this square here, and for this square then, I'm going to look at it in 2 ways. The area of the square can be found by saying base times height. That's one way. But we've also found out that you can take any shape and cut it into pieces and find the area of the pieces. So another thing I could do is add these 4 white triangles. They're all the same triangle, but add those 4 areas together with the green C square that's here in the middle. That's another way I could find it. So let's take a look at the area found those 2 ways. So the first thing I can do is base times height. So the question is, in this square, what is the base? Well, this is A plus B. It's the B side plus the A side of my triangle, so I get A plus B, and every one of these sides is A plus B. And so when I do base, I get A plus B, and when I do height, I get A plus B. Now, a lot of students want to say that this is A squared plus B squared. That's just not true. You have to remember that when you have 2 binomials, you have to do something to them. That thing that you have to do is called foiling. You need to FOIL these 2 binomials together. And so we go first times first is going to be A squared. We go outer is going to be AB. Inner is going to be AB. And last is going to be B squared. So I get A squared plus AB is 2 ABs plus a B squared here. So we get A squared plus 2AB plus B squared. So let me be clear about what we found here. When you're finding the area of this big square that we've created, and you want to know what is that area, you take the length of the A side and square it. So what I'm talking about here is I'm just reading through this. The length of the A side and square it. Then you add 2 times the length of the A side times the length of the B side and then to that you add the b side squared. And when you do all of that, you end up with the area of this big triangle. But that's not the only way that I can find this area. I can also find the area by finding the area of these 4 white triangles plus the green square that's here in the middle. If I want to do that, I'll leave it to you to figure out that this is a square. Obviously all the sides are C, but this is also a right angle over here. And so I do have a square. You have that. That's something that you could try to prove yourself. But what is the area of my triangles in here? Well, the area of a triangle is 1/2 base times height, which in my case is 1/2, and the base is A, and the height is B. I get 1/2 AB. In a right triangle, the base and the height are the sides, and I get 1/2 AB for each one of these triangles. What about the area of my square in the middle? Well, it's base times height, and they're both the same. That means I get C squared for the area of my triangle, for the area of my square, my green square in the middle. So I say 4 times 1/2 AB, that's the area of each of my triangles, plus my C squared. Now I can simplify because half of 4, which is 4 times 1/2, is going to be 2AB plus C squared. So again, let's understand what we said here. Another way I could find the area of the triangle is to do this. And in this method, I have 2 times the length of A times B plus the length of C squared is going to tell me the area of this whole square that I have right here. Well, I now have 2 different ways of finding this same area, and the areas are equal because it's the same square. That means I can set things equal to each other. When I set things equal to each other, I get the top expression, which is A squared plus 2AB plus B squared, is equal to the bottom one, which is C squared plus 2AB. Well, watch what happens here. If I subtract 2AB from both sides, remember this is legal because I'm just subtracting the same number from both sides of the equal sign. When I do that, 2AB cancels out, 2AB cancels out over there, and I end up with A squared plus B squared equals C squared. And that's exactly what I was trying to prove. This is always true, and you can write BAM. You have now proven this is true. This was first proven true about 4,000 years ago. In 4,000 years, it will still be true because that's the way that math proofs work. They prove it's true for all time.